All right, so I wanted to do a quick rundown on homework 21. And really all this is the same proof stuff that we've been doing, but it's just a different way of organizing it. We're just going to organize it in a flow chart. So once again, it's important to visualize what is your goal. So we're trying to prove that angle E is congruent with angle A. So here's angle A and here's angle E. Now those are corresponding parts of triangles. So first thing we need to do is prove that these two triangles are congruent, okay? And so here's kind of the flow chart that goes along. So first we're gonna, restate the given. So here's the given, EC is congruent to AC, so EC is congruent to AC. Then ER is congruent to AR, ER, AR. And then this is what we're trying to prove. So as we look at that, right, so the flow chart kind of states all of our given, right, and then we can also say, so here are those two givens, right, that these are congruent. And then you guys probably already starting to recognize that that's the same segment, so we can say that RC is congruent to RC. And all of those parts can combine to give us this idea that the triangle RCE is congruent to RCA. And then we can say that, oh, triangle, so then we use side, 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 side. Now we can use CPCTC to say that angle A is congruent to angle E because they are corresponding parts of congruent triangles. Let's do another example real quick. And in this case, in all of these problems, pretty much, we're going to be given the flow chart, and we just need to fill in the question marks, right? So, for example, here, copy the flow chart, provide the missing reasons, right? So we're trying to prove that MS right here is congruent to OS, okay? And they give us that SE, this little guy here, is congruent to SU, and these angles are congruent, okay? Now, so then we know that, so SE, okay, so now we go down here and we can say SE is congruent to SU. Well, that was given, so I just write given right there. And then angle E is congruent to angle U, which is given right there. And then we know that, and then we can look at this and see that these are vertical pairs. Or vertical angles, right? And so then we have angle, side, angle. So then we can say that, look, that's going to be these triangles. So triangle ESM is congruent to triangle USO. So now we proved that these two triangles are congruent, okay? And MS and SO are congruent parts of congruent triangles, so we can say CPCTC. Now, so that's kind of what you're going to be working through as you go through this. The other thing that keeps coming up, and I just wanted to talk about real quick, is this idea of an angle bisector. So an angle bisector cuts any given angle into two congruent parts, sub-angles we could say. So these two are congruent, and they are and together they add up to this bigger angle. The way that we construct it, which I thought was kind of interesting with the compass, is first you make an arc, right? And then you move to this point and you create the same arc both here and here, and wherever those meet creates this point, and then we connect the vertex to that point. The other point is that if you take the shortest distance to this side, right, which I believe would end up being perpendicular, though I'm not sure, then this distance is going to be the same here and here. So if you created a triangle that went to that closest point, you would have two congruent sides. Now, you do need to specify that those are congruent. But anyway, the angle bisector is one of those words that keeps getting thrown out, and we haven't really talked about it, so I just wanted to talk about it real quick. All right, thanks.